everyone, I am Lakshmi, Department of Mathematics, SNS College of Technology. Today we are going to discuss about the partial differential equations. So, how to form a partial differential equations. A partial differential equation is an equation involving a function of two or more variables and sum of its partial derivatives are that function dou z by dou x is, we can note it as p, and the function dou z by dou y we can note it as q, and the second derivative with respect to x is r, and the second derivative with respect to y is t, and partially with respect to x with respect to y, both involved in the second derivative means which is yes. So here the function z is based on the function x and y. Next, an order of a function, the definition for order. An order of a partial differential equation is the order of the highest partial derivative occurring in the equation. In each equation you want to check the order, that is the highest power you want to check. Here for this one the highest power is 1 and here the highest power is 2. So this is the, for this the order is 1 and for this the order is 2. Like this you want to calculate. Next, the main concept is the formation of partial differential equations. We can form the partial differential equation in by two ways. By first one is by elimination of arbitrary constants, and the second one is by elimination of arbitrary functions. First we can discuss with the elimination of arbitrary constants. Here in this we are having two types. The first type is the number of arbitrary constants is less than or equal to number of independent variables. One arbitrary constants is equal to independent variables or less independent variables high. If it is having like this, you want to proceed the type 1. So based on this by type 1 we can see some examples. So here we are going to discuss these examples. The first one is z equal to ax plus by plus a square plus b square. In this the constants a and b are involved. We want to eliminate these concepts, these arbitrary constants. How to eliminate means nothing, it is we want to differentiate this function z with respect to x and with respect to y separately. So now we can differentiate the equation. This is, we can note it as equation number 1 and differentiate with respect to x. So here in the left hand side differentiating z with respect to x, which is equal to, and here alone the x terms we are having, so differentiating ax is a. So the remaining and all constants which is equal to 0. So we can name for this term as p. Already we know dou z by dou x equal to p. So p equal to a, we got one relation. Same thing we can differentiate this with respect to y. Here alone comes the y term. So the remaining and all constants. So dou z by differentiating dou z by dou y, which is called as q, and which is equal, in the right side we got only the term differentiating by is b. So from this we got q equal to b and p equal to a. So substituting these two values in equation number 1, we got in this equation we can replace, for instead of a and b by p and q we get the equation. So here I write with this z equal to px plus qy and p square and q square. That's all. This is the required partial differential equation we got. So this way we can get the partial differential equation. We can, let us see some more examples. So the second one is z equal to x plus a the whole square plus y minus b the whole square, and note it as equation number 1, and again we are differentiating with respect to x. So here differentiating the function is a dou z by dou x, already we know, which is equal to p, and here this is the concept of x power n, so 2x, and then differentiating x is x plus a, we get 1. Here there is no x term, so it's a constant 0. From this the left hand side p equal to 2x plus x plus a, this alone we got. In this, for this bracket alone the constant a we are having, so remaining we are doing some rearrangement, take this 2 to the denominator, that is x plus a equal to p by 2 we got. Same thing we can differentiate with respect to y. Here also we get the left hand side we are differentiating with respect to y, dou z by dou x, which is equal to q, and in the right side there is no y term, so we get 0 plus again x squared concept, so 2 into y minus b, and differentiating y minus b, which is equal to 1. So we got q equal to 2 into y minus b. From this, doing some rearrangement work, again we get this y minus b equal to q minus 2. So x minus a, y minus b, these two values we got. So these two values we can replace in this equation number 1, and we got p by 2 the whole square plus q by 2 the whole square, and squaring on take the square values, and p squared by 4 plus q squared by 4 we got. So z equal to p squared by 4 plus q squared by 4 is the required partial differential equation.